Alright, this is Mr. Anderson for Kellogg Community College. We're going to be taking a look at solving for three equations. So this is three equations, three unknowns. There's going to be a pretty similar pattern here where we're going to eliminate a letter and match up some equations, and we're all going to use the elimination method for this problem. Let me think here. You may want to actually take a look at the book because the book actually has some pretty good pictures for three-dimensional space, because what we're trying to do is trying to find the coordinate in space that these three planes intersect at, or maybe, as you see the floor, a left side and a right side of a wall, where would they intersect in the corner? The ambiguous cases where two of these planes are the same or two of these planes are parallel, we're going to have some of those near the end of this worksheet and video here. But we're going to get started here with needing three variables, like an x, y, z in the problem. Then we need three equations to solve. Now you're going to have one of these on the test, and it pretty much has its own page because you can show a lot of work. If you make a mistake, you can go back and check your answers out. Some of you might be familiar with the matrix method. In fact, one of my videos teaches the matrix method. You will not get credit for this problem unless you show out all of your work. The problem could be solved using matrices pretty easily, but really the task of this is to do many small, very simple algebraic manipulations, and to do so accurately. So this is more of an accuracy check over the long haul, and it's probably in your best interest to check your answer at the end by plugging x, y, z back into one of these three equations, if not all of them, and see if that actually works. Well, what we're going to do here is we're going to analyze these three statements. I prefer to eliminate a letter, and I like to go with letters that are opposites. So what strikes me right away is that the x's are all positive, so we're not going to try to eliminate the x's. But the y's and the z's are pretty much, as you see there, the y's and the z's are already opposites. So I think let's go ahead and try to eliminate the y's here. What I'm going to do is work on the first and second equations. Now, what's great about the first and second equation is that these y's are already opposite. So if I double the first line right here and make it 2x plus 2y plus 2z, 2z, there we go, is equal to 8. Make sure when you multiply everything, you got to do it to every term. Don't forget about multiplying the 4 by 2. And then this is just going to be moved over, multiplied by 1, if you want to think of what scalar is getting multiplied by that. Then we're going to add these up. Now those simplify to 0, so I got 3x, and over here I've got minus z is equal to 9. Now I like going opposites because I like adding straight down these columns here, so 2 minus 1z is just positive 1z. Good thing I checked that. Oh, almost made a mistake there. Alright, so now what I'm going to do is I've got to pick another pair. So I can either pick the middle and bottom or the top and bottom, and I have to eliminate the z's. So your first step was to pick a pair, eliminate a letter. And I said z, I meant y. And then you're going to pick another pair and eliminate the same letter. So I'm going to eliminate the y's from this middle equation. Should I do that? No, I think I'll choose, instead of the middle equation, I'm going to choose the top equation. And because the top equation can be written just as x plus y plus z equals 4. And I'll choose the bottom equation, so that's 2x, in this case, minus y minus 2z is equal to negative 1. Alright, so what I have here is I have 3x, the y's simplify, and this here makes a negative z right there, and then this is equal to 3. Alright, what's cool about this is now I've got two equations and two unknowns, so what I'm just going to do is bring these two together and stack them on top of each other. And I don't have to do any manipulation with this because you'll notice that if I stack the 3x plus z equals 9 and the 3x minus z equals 3, what I get is a super simplification of the z's. They go away without any work because they're opposites, and this makes 6x is equal to 12, so x is equal to 2. Now what's nice about that is now I have one of my three answers to the problem. I'm going to take that 2 now, and I'm going to plug it into one of these two equations, the top equation here, or this one over here on the left. I'm going to choose the equation with the fewest number of negatives because that's where most people make mistakes. So I'm going to choose this equation. So now I have 3 times 2 plus z equals 9. All right, so that's going to make 6 plus z is equal to 9, and subtract 6 from both sides. Z is equal to 3. All right, well, that's pretty nice. I got x equals 2 and z is equal to 3. And now what I'm going to do is plug any of these numbers, the z and the x, back into one of my 3 original equations to figure out what my answer is there. And if I'm choosing the equation with the fewest number of negatives, well, that would definitely be the top line right there. So that would be 2 instead of my x, plus y, the variable I need to find, plus 3 is equal to 4. So this means y plus 5 is equal to 4, or y is equal to negative 1. That's after I subtract 5 from both sides. Well, there's my answer to the problem. These 3 planes intersect at 2, negative 1, and 3. Now, it would benefit me to take this answer and plug it into one of my other 2 equations and see if it actually checks out. So this is 2. I'm going to plug it into the second equation here. So 2 minus 2 times negative 1 minus 3 equals 1. So this is going to be 2 plus, let's see, 2 plus 2 minus 3 equals 1, or 4 minus 3 equals 1. Check. All right, so there's my check for the problem, and I can verify that my answer is right. If you really want to go overboard, you can do it to the next equation too, but you know, probably after all this manipulation, you'll want to kind of rest a little bit. All right, well, here we go. Gonna start up this problem here. This is gonna be a little trickier here. Got some bigger numbers to look at. So let's give this a try here. Now again, let's analyze the problem. I notice all my x's are positive, so probably wouldn't be a good idea to try to eliminate x's. Even though like this is pretty desirable right there. Maybe I should go for the x's. Now, I mean, the y's are also going to be kind of good because you have a y and a negative y here. And the z's, you just have to turn one of these negative. You know, maybe I'll go with the y's just because I can take this first line and the third line, the first and third equation, and I can just put them right on top of each other and have the y's simplify without any work at all because I already have opposites there. I know that some teachers have talked about doing these where you want to get them the same and then subtract, but man, I tell you what, we make a lot more mistakes subtracting than we do adding. So this is going to be 3x, negative 3 plus 1 is negative 2z, and this is going to be negative 13. Boy, that's weird looking, isn't it? All right, so we've done the top, and we've done the bottom. So now we have to do the middle equation with one of these two. I think I'm going to do the middle line right here, the 2x plus 3y plus c equals 6. I'm going to do the bottom line. And the reason why I chose the middle and bottom instead of the middle and the top is that the middle line and the bottom line actually has a negative for the y. So if I multiply by 3, then I'm going to get my 6x, my negative 3y, plus 3z, and then 14 times 3. 14, 28, 38, negative 42. All right. This is going to be 8x. These are going to simplify out. This is going to be a 4z. And this is going to be 6 and negative 42, negative 40, negative 36. All right. So what I'm going to do now is I'm going to stack these equations on top of each other, this one here and this one here. And let me analyze what would be easier to cancel. Let's see here. Would it be easier to cancel the x's or the z's? I think the z's would be better since one of them is negative already. And if I double this equation, so multiply by 2, this gives me 6x minus 4z is equal to negative 26. And then here I'm going to have 8x plus 4z is equal to negative 36. All right, so now the z's go away. This is 14x. And this is going to be, let's see, 12, carry the 1, negative 62. Something about that doesn't seem right. Let me see. 14 into 62. 28. Let me see here. Oh, I see. That's where the mistake is right there. The 4 and the negative 14. Okay, I found that. The 4. Okay, so here's what happens. 4 and negative 14 make a total of negative 10. Okay, so when I multiply that 2, that gives me negative 20, and this gives me negative 56. Okay, now that's better. That's better, because this x, then if I divide by 14, haha, then x is going to be equal to negative 4. All right, well, that's an easy... Sorry about that mistake there. At least nobody was watching, right? So we've got x equals negative 4. So now what I'm going to do is take that negative 4 and plug it back into one of these two equations. I'm going to choose this equation down here just because there's fewer negatives. So now that I know my x, I'm going to go 8 times negative 4, which is negative 32, plus 4z equals negative 36. Get to add 32 to both sides. Ooh, this is going to turn out pretty nice. So 4z is equal to negative 4. Z is equal to negative 1. All right. So, nice whole number answers. Another tip that you're probably doing the problem right, because you'll probably not get decimals unless they're easy, like 0.5 or 0.25 or 0.75. So if you're getting wonky decimals, go back and check your work. That's why when I did this problem over here, immediately saw my answer was wrong, because it's like, yeah, I don't think it turns out as a decimal. All right, so I've got negative 1 for my z, and my x is negative 4. I think the middle line doesn't have very many negatives, so I'm going to plug in my x here. That's 2 times negative 4, plus 3 times y, plus my negative 1 equals 6. So I've got negative 8 plus 3y minus 1 equals 6. 3y minus 9 equals 6. Add the 9 to both sides. 3y is equal to 15. Y is equal to 5. Wow. Okay, so my answer set is negative 4, 5, negative 1. And actually, I think I should probably go back and check this answer. So I'm going to go back to the top line and try my little check. I'll put a little box here for the check. So this is going to be negative 4 in for my x. I'm choosing the top line right here. It'd be silly to plug it back in the middle line because that's what I just used. Plus 5 and minus 3 times negative 1. I'm showing my substitution with parentheses. So this is going to be negative 4 plus 5 plus 3 equals 4, or negative 4 plus 8 equals 4. Ba-bam. All right, so apart from my small mistake right there, that's pretty much that. Okay, so we got 2 more problems here, and the reason why I'm doing these 2 problems, I will tell you, spoiler alert on these 2, these do have some problems with them. Like, you're going to get down past the first step and then see the kind of trouble you'll get into. So let's actually cover it. So let's see, analyzing this right now, it looks like eliminating the y's is going to be the best bet, because you can see that the middle and top and the middle, bottom and top, you can, by putting these together, like the middle top, if I just multiply this by 2, then I'll get 2x minus 2y plus 2z equals 8. And then this is 5x plus 2y, see there's my match, minus 3z equals 2. All right, ba-bam. So I got 7x minus z equals 9. So I've just got to pick another pair. I'll pick the top line, multiply it by 3, since the bottom line already has a 3y. So the top line becomes 3x. Shoot, I just wrote a plus, but okay, plus negative 3y plus 3z equals 12. And then down below, we're going to go 4x plus 3y minus 4z equals negative 2. So this is going to be like that. All right, so those simplify. So I got 7x, over here I got negative z, and over here I got 10. All right, now I'm going to stack these 2 on top of each other. 7x minus z equals 9. I know, you might be shouting out, but don't you see what's going on here? Yeah, I do. Actually, 8 and 2 make 10. So, whoops. Gotta fix that right there. So 8 and 2 make 10 instead of 8 and 2 make 9. So I stack this on top and I stack this on top. And you'll notice that they're exactly the same things. So if I subtract them or multiply this one by negative 1, I get negative, positive, negative. So you get an answer of 0 equals 0. What this means is that my problem here, it has some consistent answers, which means that two of these planes are exactly the same. So what this means is that, usually you're given, one plane going one way, one plane going another way, another plane going here, and you're trying to find the intersection. But in this case, two of your planes are exactly the same, and then there's a third plane which we haven't tested yet. But what this means is that this is going to intersect at a line, and this right here, this technical all solutions, isn't really all solutions. It's just there's an intersection on a line here, and we don't know where that line is. So this problem is unsolvable in terms of an X, Y, Z answer, but this is one of those situations where you have two planes that are exactly the same. So that's about the end of this problem. When you get to a situation where you have 0 equals 0, or that consistency, then pretty much we're done. That won't happen to you on the test with these three-dimensional problems, but it might happen in your homework. All right, so for this final problem here, let's, another spoiler alert, there's going to be a problem with this one too. So let's tackle the y's like we have been, just because the first y is positive, the second y's are negative. So if I multiply this line by 3, I'll get 12x plus 3y plus 3z is equal to 17 times 3. Couldn't make it easier, could I? 30 and then 21, 51. Okay, so this is going to be down here, x minus 3y plus 2z is equal to negative 8. All right, so what's going to happen here is I got 13x, these simplify, 5z is equal to 51 minus 8 is like 50 minus 7, 43. All right, now I'm going to take the top line, multiply it by 2. Take the bottom line, keep it the same, because now, the reason why is because look at my bottom line, 2y plus 3z equals 5. You see that bottom line, it's okay, it's the negative 2 there. Okay, so we multiply the top line by negative 2, or positive 2. 8x plus 2y plus 2z equals 17 times 2, which is 34. All right, so put this together here, got 13x, these simplify, 5z is equal to 34 and 5, 39. I'm going to stack these two on top of each other, 13x plus 5z equals 43, and I got 13x plus 5z equals 39. Well, what's going to happen if I multiply this by negative 1, I get negative, negative, negative. So I get zeros here, because those simplify to 0. And this does not make 0. This actually makes a positive 4, and this is an inconsistency. There is no solution, because what happens is that two of these three, actually, all three of these, but at least we know that two of these planes are parallel. So there is no intersection. So even if we have another, a plane that, intersects them like the side of a shelf right here, it's still not going to give us one answer for these. Build some nice shelving units, but it just doesn't work here. So nope, no solution on this one. And the book also has better pictures than what I just scribbled up here, but you won't receive any, these last two problems that had these issues, they won't be on your test, but they will be in your homework. And you'll notice at the bottom of this worksheet, it says matrix notes. There's a video that I've made for solving these with matrices, so you may want to check that out if you want a good way to check your answer. But all the work that I showed you, you need to show that on your test. So thanks for watching, and again, sorry for the little minor mistakes here, but please, thanks for watching, and send me some feedback or emails. All right, take care.